What are moles? Many people don't like moles in chemistry. I think it's because generally they think it is an object, but in terms of chemistry, moles is just a number. So if I was to say you had a pair of socks, you'd know that that would be two socks. Or if I said you had a dozen eggs, then a dozen eggs, of course, would be 12 because a dozen is 12 eggs. But equally, I could then go, well, what if you actually had half a dozen eggs? Well, if you had half a dozen eggs, you just have half of that. So half a dozen would be 6 eggs. A mole is the same, where a pair is 2 or a dozen is 12. A mole is just a number like that, but the number maybe is a little bit more complicated. In terms of moles, the number of moles that we have is quite a big number. We can shorten it sometimes to standard form to 6.02 times 10 to the 23. This is called Avogadro's number. You probably are better to learn this one as opposed to this one here because it's really going to be hard to learn all that. Really, it's just a 6.02 and you're moving the decimal place across 23 times. But what's maybe more important again than being able to understand just what moles is and learn that number is actually being able to calculate moles. So moles is calculated by the equation moles equals mass divided by mR. So if you know the mass of a compound and you know it's mR, which you can work out, there's not another video to watch that if you need to, then you can work out your moles. Now the important thing is your mass must always be in grams. So if a question was to give you it in kilograms, multiply it by 1,000 to get it into grams. Or if it gives you anything else, you need to convert it into grams first. So mass must always be in grams. The other thing, of course, then is important to be able to rearrange this equation. So if I was to bring my mR up, and of course if you bring something over to the other side like that, then you are essentially multiplying it. And if we get rid of that division sign, we're saying mR times moles is equal to mass, or to flip that equation around so it makes a bit more sense, mass is equal to mR times moles. So that then essentially is leaving us with two equations. Mass is equal to mR times moles, and moles is equal to mass divided by mR, remembering that the mass is always going to be in grams. So if you're calculating it, you're working out your mass in grams, or you're using your mass in grams, and then you could convert it into kilograms if you wish after that point. Of course, you could use this equation as well. You could make mR the subject of the equation, but you're not going to have to do that very often. Some people like to use triangles whenever you have equations with three things in it. So your triangle for this equation would be a big, long, thin triangle. Now this is something that was taught to me. It makes no sense, but I've never forgot it. If you draw a big, long, thin triangle instead of just a regular triangle, the only thing that will fit there on the top line is a big, long G. Why a big, long G? Well, of course, this is going to be your mass, and your mass must be in grams. Nothing else will fit in there. And the most important thing whenever you are doing these triangles is what you have the top line is right. So it must be a G on the top line. It cannot go anywhere else. The bottom line, well, the bottom line is good old Mr. Moles. Mr. Moles is down the bottom. Now, if you are trying to use these triangles, what way it works is you cover up whatever you're trying to work out. So if I want to try and work out what my mass is equal to my moles times my mR, or my mR times my moles. Okay, I'll give you the same answer because they're side by side. So if they're side by side, you multiply them. If I'm trying to work out my moles, I cover up moles, and my moles is my mass in grams divided by my mR, because grams is on top of mR. So anything which is divided down, top and bottom, Anything which is side by side is multiplied. As I said, we could work out our MR as well. Cover up MR. MR will equal grams, mass in grams, divided by moles. But it's very, very rare you will ever have to use that. So let's look at two quick examples of this. How many moles are in 88 grams of carbon dioxide, CO2? So the first thing we need to work out is we need to actually work out our MR. We're given the mass, but you don't know the MR, and you're trying to work out the moles. So we're going to say that moles is equal to mass over MR. So I need to work out this MR. So I have carbon dioxide, CO2, that's 1 carbon and 2 oxygens. So it's going to be equal to 1 times 12 plus 2 times 16, which is equal to 44. So my MR is 44. My mass is 88, so my moles is going to be equal to my 88 grams divided by my 44, which is going to equal to 2. So there are 2 moles of carbon dioxide in 88 grams. In the second example, what is the mass of 0.25 moles of water, H2O? So this time, because we're trying to work out the mass, we're going to say that mass equals moles times MR. So again, I need to work out my MR. So my MR of H2O is going to be 2 hydrogens and 1 oxygen. So it's going to be 2 times 1 plus 1 times the 16, which is equal to 18. So the mass equals 0.25 moles multiplied by my 18, which is going to equal 4.5 moles. Sometimes whenever you're writing that, you may see that just written as MOL. MOL is the unit for moles, just like G is the unit for grams. So remember, moles in chemistry is just a number. You could have a pair of oxygen atoms. You could have a dozen or a half dozen of oxygen atoms, or you can have 1 mole of oxygen atoms. If you had a pair, that would be 2. If you had half a dozen oxygen atoms, that would be 6. If you had 1 mole of oxygen atoms, that is this 6.02 times 10 to the 23 atoms.